kids, my name is Lanisa Nunian and I am going to be your resident scientist for the upcoming school year. I'm a 4th year graduate student at the University of Texas in biomedical engineering. Today I'm going to take you on a journey into the world of biomedical engineering. Hi, I'm Ryan Seacrest and welcome to Academic Idol. Today we're going to showcase some of the most promising young scientists at the University of Texas at Austin in the biomedical engineering department. Okay, so let's hear from our first contestant of the day, Prenda Winnacol.
Hi, my name is Prenda Winnacol. I'm in my 3rd year of the biomedical engineering PhD program here at UT. I'm actually working on creating new drug delivery systems for multiple sclerosis treatment. Today what I'm actually doing is I'm preparing a new material. It's called a hydrogel and it has several different components in it. And I'm actually cutting them down into smaller pieces because I'm going to use a machine called a cryomill. The cryomill actually will freeze these using liquid nitrogen that's about negative 180 degrees Celsius. And then it'll pulverize them into small microparticles. And the microparticles can be compressed into a tablet for you to take your treatment.
Ingestible microparticles? What does that mean, Simon? Well, Paula, what that means is that she's going to make a drug in pill form that you can take by mouth. What do you think, Randy?
Baby, a way to start it off, man. Yo, the competition's on, baby. It's on!
Indeed, Randy. It looks like it's shaping up to be an exciting competition. Now, for our next contestant.
Hey kids, my name is Abhi Kudva and I'm an undergraduate researcher. And today I'm going to show you how to use a separation funnel in chemical synthesis. This is a separation funnel and it's used to separate an aqueous solution from an organic solution. So after you shake it, you have the aqueous solution on the top and the organic solution on the bottom, and that's because the organic solution is more dense and it collects on the bottom, and you can see the separation layer right about here. Sometimes when we synthesize chemicals, we have excess solution, and to get rid of that excess solution, we use a rotovap. After rotovapping, we slowly pour solution into acetone to precipitate out our final product. As you can see, our final product is a white, cloudy, cotton candy looking substance that collects on the stirring rod. Ultimately, I want to be a medical doctor, and I believe this research experience will provide me with invaluable lessons for my future career.
Aqueous and organic solutions? Polymers? Simon, I'm so confused. Paula, he's just showing us the methods on how to make polymers. Randy, do you have anything else to add?
Like, yo, man, this kid is ready to go.
That's right, Randy. He's going to medical school next year. Let's hear from our next contestant.
My name is Eileen Dawson and I'm a 4th year graduate student currently working on creating a vaccine. Currently I'm making particles that I coat on the slide. That's the white dusty film that you see on the slide. Then I add negative charges to the surface of the particles that would attach to positively charged proteins, like magnets. The ultimate goal of my project is to design a vaccine that will cure cancer.
Vaccines for cancer? That sounds nice. Yes, Paula, that is very impressive.
You were the bomb tonight, baby. That was hot.
A vaccine for cancer? That is hot, Randy. Let's see who our next contestant is.
Hi, my name is Adrian Pontecorvo and I'm a 5th year grad student here at UT Austin. And my research involves using lasers, like the one you see behind me, to image the brain. And a laser is just really powerful amplifying light. And by shining it on the surface of the brain, we can figure out what's going on. And what we try and do is take a look at things like strokes and migraines, and using the laser light, see what happens during those things, so we can hopefully one day find cures for them.
Lasers? I thought they were used to destroy aliens. Apparently, they can also be used to image the brain.
That was cool, man. It was kind of hot.
Looks like the competition is heating up. Hopefully our next contestant is prepared.
Hi, my name is Mary Haldera-Moore, and I am a fourth-year graduate student in the biomedical engineering department. My project involves the development of shape and size-specific nanoparticles. So nanoparticles are probably about 1/10 of the actual diameter of your hair. And these are some of the particles that I fabricated using this imprint lithography method. But using this method, I can make all kinds of shapes, triangles, pentagons, squares, you name it, I can make it. And the ultimate objective of these particles is to change the shape and size and see where they go within the body to be used for cancer-seeking drug delivery vehicles.
Simon, how small is the nanoparticle? It's smaller than the diameter of your hair.
Yeah. Hot fire! Fire!
On to our next contestant.
Hi, I'm Johnny Wu, and I'm a third-year biomedical engineering graduate student. I study computational biology, which means I study the structure of molecules. For example, this is trypsin. It's created by the pancreas. Making too much of it is associated with pancreatitis, which is why we want to look at the structure of it to see what compounds combine with it to inhibit its activities. This is useful in creating drugs, and that's why computational biology is important.
When I got my PhD in computational biology, I learned that you can discover drugs much, much faster with this method.
Once you got started, it was like going on. I was like, what?
Yes, Randy, I agree. On to our next contestant.
Hi, I'm Srivalisha Malidi. I'm a final-year graduate student trying to get my thesis done and trying to graduate soon. I have had a blast in this BME department. My project is basically about diagnosing, imaging cancer at a very early stage. So what I do is like make gold nanoparticles, try to inject them in mouse that have tumors and see how these gold nanoparticles are interacting with these tumor cells, if I'll be able to image at an early stage and things like that. Right now I don't have any mouse here, but I do have some cancer cells that I'm trying to see if the lasers and gold nanoparticles will actually kill them or not.
Gold is shiny! Yes, Paula, gold nanoparticles are important in cancer research.
Yeah, I like this.
I like that too, Randy. Now, for my favorite contestant, Miss Lanisa Nguyen. And now I'm going to show you exactly what I do in my research. So I make two different layers with these materials, and I put cells in them, and these materials act as a temporary shelter to house the cells so that they can survive within the body. Once I put the cells into these materials, I put them in a solution called media, which provides them with nutrients so that they can survive. And I have one for bone layer and one for the cartilage layer. And once they become bone and cartilage, I can combine them to make a hybrid tissue of both bone and cartilage. So the ultimate goal of my research project is to be able to tell the cells in these hydrogels to become both bone tissue and cartilage tissue at the same time. Simon, what's a hydrogel? Well, Paula, they act as a home for the cells.
Wasn't really, just kind of boring.
What are you talking about, Randy? That was by far the best contestant we've ever had.
Keeping it real, keeping it real.
Wow, we saw a lot of talented young scientists today. And hopefully they gave you a good idea of what cool things biomedical engineers can do. This has been Academic Idol. Until next time, Ryan Seacrest signing off.